Hello friends, welcome to Trodiac. In the last video, I have posted this question and asked you to solve this. So let's discuss the solution of this question. So first you have to observe that this wedge and the sphere cannot have arbitrary accelerations. Okay, they are connected by a string. So if you assume x capital M be the distance of the wedge from this pulley, x capital M, and L naught be the distance between these two pulleys, and x small m be the distance of this topmost point from this pulley on the wedge. Okay, so we can write x small m plus x capital M plus L naught plus x capital M equal to constant. Okay, this total length of the string is constant. Okay, but L naught is also a constant, so that implies xm plus xm plus 2 x capital M equal to constant. If we differentiate this with respect to time, we get Vm plus 2V capital M equal to 0. That implies V small m equal to minus 2V capital M. So this minus sign implies that if the wedge moves right, the sphere moves down. Okay, and the velocity of this topmost point, that is what derivative of this dxm by dt is the velocity of this topmost point with respect to wedge. This xm is with respect to wedge, is equal to minus 2V capital M, 2 times the velocity of the wedge. Okay, that is what we got from here. And also the bottommost point, this point, has velocity 0 with respect to wedge. Okay, because it is rolling on the wedge. But this is a rigid body. So this point has velocity 0 and this point has velocity 2V capital M. So what will be the velocity of the center? V capital M. Okay, so that implies omega called Vm by r rotation. This body is rotating in anti-clockwise direction with omega angular velocity. As this is a rigid body, we get omega called Vm by r. Very simple. Okay, now if we differentiate this with respect to time, we get alpha equal to A capital M by r, where am is the acceleration of the wedge. Okay, now what are the unknowns? We don't know the acceleration of the wedge and the sphere, tension, normal force and frictional force. Okay, these are the unknowns we have to find. So we find them by writing down the equations, Newton's second law and torque equation. So first, if we write the Newton's second law for the wedge along x direction, we have 2t minus t cos theta minus f sin theta. Friction, this friction normal force on the sphere due to wedge. So on the wedge, we have friction in this direction, normal force in this direction. Okay, so 2t minus t cos theta minus f cos theta plus n sin theta will be capital M A1, mass times acceleration. Also for sphere, we got V capital M as the velocity of the center of sphere. So what will be the acceleration? A capital M, but we assumed A capital M as A1. So A1 is the velocity of acceleration of the center of the sphere with respect to wedge. Don't forget, this xm is with respect to wedge. So Vm and Am are with respect to wedge. So with respect to ground, the acceleration, to find the acceleration with respect to ground, we have to add the acceleration of the wedge as well to the relative acceleration of the sphere. So relative acceleration of sphere is A1 down the wedge and acceleration of the wedge is towards right. So we have to add these two. This is relative velocity and this is the acceleration of the wedge. So net acceleration will be vectorial sum of these two. Okay, now if we resolve this A1 into A1 cos theta and A1 sin theta into two components, normal components, acceleration along down the wedge will be a1 into 1 minus cos theta, and acceleration perpendicular to the wedge will be a1 sin theta. So forces acting along the wedge are mg sin theta. mg if we resolve in two components, mg sin theta and mg cos theta. So mg sin theta minus t minus f. mg sin theta minus t minus f, okay, equal to ma1 into 1 minus cos theta, acceleration along this direction, and mg cos theta minus n, mg cos theta weight minus n is acting upwards, so minus n, mg cos theta minus n equal to ma1 sin theta. Also the sphere is rotating, so what will be torque in anti-clockwise direction? Friction is acting along this direction and tension is acting along this direction. So net torque in anti-clockwise direction will be F minus T into R equal to I alpha, moment of inertia of sphere 2 by 5 mr square into angular acceleration alpha. That gives F minus T equal to 2 by 5 mr alpha. But R alpha is A capital M, we got it from here. If we differentiate this, we got alpha equal to AM by capital R. A capital M is nothing but A1. We assume acceleration of wedge as A1. So R alpha equal to A1. That gives F minus T equal to 2 by 5 MA1. So now if we add these two equations, this equation and this equation, friction will get cancelled. So what will be the equation? mg sin theta minus 2t equal to ma1 into 1 minus 1.4 minus cos theta. That gives if we solve it, if we rearrange this, we get tension equal to 0.5 mg sin theta minus ma1 into 0.7 minus 0.5 cos theta. If we substitute back this in this equation, we will get friction equal to 0.5 mg sin theta minus ma1 into 0.3 minus 0.5 cos theta. And from this equation we get normal force. From this equation we get n equal to mg cos theta minus ma1 sin theta. mg cos theta minus ma1 sin theta. So now we got tension, friction and normal force in terms of theta and a1. So if we substitute these three in the first equation, 2t minus t cos theta minus f cos theta plus n sin theta equal to capital M a1, we get, if we take t common, we get 2 minus cos theta into t minus cos theta into f plus sin theta into n equal to m capital A1, capital M A1. So if we expand this equation, we get this equation, and sin theta cos theta terms will get cancelled, okay, minus 0.5 mg sin theta cos theta minus 0.5 mg sin theta cos theta and mg sin theta cos theta. These three terms will get cancelled, and from the remaining terms, this cos square theta terms and sin square theta terms will be added. We take this 0.5 ma1 cos square theta and minus 0.5 ma1 cos square theta. It will be minus ma1 cos square theta and minus ma1 sin square theta. So if we take minus ma1 common, it will be sin square theta plus cos square theta. So it will be 1. So it will be minus ma1. And from this remaining equation, we will get mg sin theta. And if we take ma1 common from these remaining terms, we get 2 cos theta minus 1.4. So from here we get mg sin theta plus ma1 into 2 cos theta minus 2.4 equal to capital M a1. So from here we get acceleration equal to mg sin theta by capital M plus small m into 2.4 minus 2 cos theta. Okay, theta is the angle of wedge. We know that capital M and small m are known. So this is the acceleration of the wedge. Okay, this is the acceleration. Okay, so this is how you have to solve this question. Okay, first write down the constraint equation and then write the Newton's second law and then rotation torque equation. Okay, very simple question, very simple if you know the concepts clearly, correctly. Okay, so if you like this video, please subscribe to my channel. Okay, thank you.